This is video 1 for the ANCOVA assignment for Psych 642. In this video, I will be providing a brief description of what an ANCOVA is, when it should be used, how it does what it does, and what some of the specific assumptions and types of data are needed in order to run and use this test. So before I can talk about ANCOVA, I have to kind of briefly go back and give an explanation for what an ANOVA is, because they build, the ANCOVA builds on top of the basic ANOVA model. So an ANOVA compares the means of 3 or more groups to determine if a difference exists, and an ANCOVA adds a covariate, which is a variable that is related to the dependent variable but is not part of the main experimental manipulation. So basically what that means is it's not part of what you're manipulating, but it's something that can affect your outcome. So specifically, the ANCOVA should be used in 2 specific scenarios. The first is when you were looking to explain some of the within group variance in terms of the covariate. So like I just mentioned, some of the variance that occurs in your outcome is due to your covariate, if a covariate exists. So if you know that covariate exists, you would want to use an ANCOVA in order to reduce the error variance and allow a more accurate assessment of the effect of your independent variable. So it allows you to account for more of that unknown variance, so that if there is an effect based on the known variance of your treatment or whatever your independent variable is, then you'll be able to detect that. The second instance that you may want to use an ANCOVA would be if you know that a confounding variable exists. So for instance, you're doing an experiment and you're not able to control for all of your confounding variables. You could use an ANCOVA. You would add the confounding variable in as a covariate in the ANCOVA model to remove the bias of that variable using the statistical control, since you didn't control for it in your actual experiment or in the design of your experiment. So the ANCOVA works as a slight modification of the way an ANOVA works. So briefly, an ANOVA uses the F statistic, which basically just looks at comparing the amount of systematic variance to unsystematic variance. So the systematic variance is the variance explained by your model. So if you're doing an experiment, the amount of variance explained by whatever your treatment is or whatever your treatment groups are. Whereas the unsystematic variance is all the other variance that's unaccounted for by your model. So basically it's a comparison of how good your model is to how bad it is. And this is done by looking at the sum of squares, and specifically looking at the sum of the squares of the model divided by the sum of squares of the residuals or the unexplained variance. So when you add a covariate in, this explains some of that unsystematic variance and it removes it from the comparison. So if there is an effect from your systematic variance, if there is something there, it'll be easier to find once some of the unsystematic variance has been accounted for. So that is kind of the gist of how that works. It takes some of the unsystematic variance away because it's accounted for and allows you to see better whatever effects may be there as a result of your model or your systematic variance. So what does this test need in order to function properly, in order to be able to use this test? Obviously, you're going to need a covariate variable in order to do an ANCOVA. And that variable specifically needs to be a continuous covariate variable. As far as the other data requirements, there also needs to be, just as for an ANCOVA, a categorical predictor variable with at least 3 levels, so 3 or more. And then there also needs to be some type of continuous outcome variable that you're looking at. And that's going to be, you're going to be looking at the means of your 3 or more levels on the outcome variable to test to see if there's a difference. Several different assumptions need to be met in order to be able to use this test. So all of the assumptions of parametric tests and the ANOVA need to be met in order to do the ANCOVA. Those include homogeneity of variance. The data needs to be normally distributed. It needs to be interval data in order to work. You need to assess to make sure that the residuals are normally distributed, that there's randomness, independence, all of those things that you would normally look for an ANOVA or a parametric test. In addition, the ANCOVA has 2 other assumptions that need to be tested. The first is the independence of the covariate and the treatment effect. So there needs to be no relationship between the continuous covariate and the categorical groups. So for instance, if you were to run an ANOVA specifically on those, you would need to find no significant difference in the levels of whatever your covariate is between the different treatment groups. The second extra assumption that needs to be tested for ANCOVA compared to ANOVA is the homogeneity of regression slopes. So the ANCOVA, when you run it, it assumes that all of the groups have a similar relationship. So they have the same slopes for their regression lines. It combines it kind of all into one model. If they don't have the same or similar regression slopes, then your model is not a good fit for what for the data that you're trying to represent. So you would need to pick a different test or possibly use a more robust method. And that's the same for all of the other assumptions as well. So that concludes video 1 and our brief discussion of what an ANCOVA is in relation to an ANOVA, as well as when you should use it, how it works, and what you specifically need in order to run this test.